Hi, Sid. Good evening.
Hi, Kranti.
Hey, hope you had a great weekend.
Yeah, it was good.
Okay, right. Uh, yeah, a small note here. So,
Mm-hmm.
on September 3rd, that is on Monday, coming Monday, due
Mm-hmm.
to Labor Day, there'll be a break for the training session.
Okay.
Yeah, so, I also have sent you a mail.
Yeah, I got the email, Kranti.
Yeah. So, we'll resume the classes from the next day, September 4th.
Okay.
Okay,
Yeah.
right. So, in the last day, we have covered calculations. So, have continued from the number functions. So from ABS function, we have moved to trigonometric functions. So we
Mm-hmm.
have seen different trigonometric functions and also inverse trigonometric functions, degrees like radians, power square, and so. Uh, Later on, I mean, we have discussed Zn function, also some exponential functions and logarithmic functions. Okay, like
Yeah.
yeah, like ceiling and floor. Okay, so we have discussed those, and we have also looked into string functions like char, boolean, ends with. Okay, so we also have looked into substring functions like left, right, mid. Okay, and mm, we also looked into trimming functions like r trim, l trim, n trim. Okay, so also length functions in the trimming functions. Um, in in replace functions, we have looked into the replace function where we can replace one uh, with the other text. So in case functions, we have looked into uppercase, lowercase, and also in space functions, you have looked into um, min and max. Okay, so we also looked into find function and also find nth function. We also looked into split function as well. Okay, so in the last section, we have started discussing about date functions. In date, we have looked into year, month, day, and also date part and date name. So we'll continue from there uh, in, in doing some tasks on date part and date name. So in the last class, we have discussed about date part. So, I'm opening a web workbook and then connecting to the data. Date part and date name. So we have discussed that date part actually returns a integer and date name returns a string. So we'll look into some examples of this. So we'll implement date part and date name dynamically. We'll look into date part and date name with an example to show it dynamically using a parameter. Okay. So the first we'll create a parameter and name this as date part. Uh, and the type is string because this is a date part that we will define here, and the allowable values are a list. So in this list, the strings that we will use are year, quarter, month, week, and day. All will be in almost be in lowercase. Year, quarter, month, week, and day. Okay, and we'll display the parameter by right clicking and clicking on show parameter control. So we'll have a parameter control in the view like this. Now we'll create two calculated fields, one for date part and one for date name. First we'll prepare date part calculated field. The formula that we'll use is date part of the parameter date part so it's in purple, so it's a parameter comma order date. So this is the syntax for date part function. So in date part, first we will have to take the date part that you want to use and then the field. So in the or date field. So the date part is dynamically used using parameter here. So we are actually including a dynamism using a parameter control here for date part. So this is date part, and we'll create one more calculated field for date name. So here syntax is date name of parameter date part comma order date. Okay, so now we have created two calculated fields, date name and date part. So date name will be present in dimensions as it is a string output. So the output of a date name will always be in string. So it will be directly in under dimensions. However, date part would be created um, under measures. So we'll convert date part which is under measures into dimensions by dragging and dropping into dimensions field. Okay, now date part is a calculated field which is under dimensions. So we'll drag date part and date name into rows now. And we will change the parameter and then check the different options that we have. So based on the dynamic selection that we give in parameter control, the date part and the date name appears in the view like this. So this is how we can use the date part and date name functions. Okay. Now, so we'll go into the next example, next function, which is today and now. So today, so there are two types of functions, today and now. So today displays current date, whereas now displays current date plus current time. So now displays current day and current date and current time. So you have to note here that today and now will take the local system date and system time. Okay, so the local system date and system time would be defined by workbook local here. So here we have to, so if you are in a US geographical region, you have to select US here. So it will show the US time. Okay, if you are in India, you have to select English local so that the date, the time also changes. So we'll see how it functions. So right. So now in this task, we will implement today and now in Tableau. So we'll create two calculated fields, today and now. This is today, and I'm duplicating this. and making it as now. I'll edit this, rename it to now, and change the function to now. Okay. You have now, and see it is a date and time field now. So now is a date and time function. So that's why you're getting an icon where you have a calendar plus a clock icon. So which is a indication for date and time field. Whereas today is a date function. So indicated by a calendar icon. So which means it has only date data into it in it. Okay. It doesn't have time data. It only has date data. Right. So today returns date data, and today function returns date data, and now function returns date plus time data. Okay, right. So we'll drag this today and now into rows. Okay, um, and right click on both the both the calculated fields and choose exact date and discrete. We'll choose exact date and discrete. So today gives us the day, and now gives us the day and time. The day and time. Okay. Here you can change the locale to uh, English India. That will display the local time. That will display the local time. If you have automatic user local, so that will take the default time which is set before. So if you are changing time zones, so it will take some default time zone. So if you want a specific time zone, so you change the locale to your time zone. Right. So this is about today and uh, now. Also, we can create time parts from now as well. So, for example, um, we can create a parameter. So, we'll create a task now wherein we'll extract time parts from um, today. So, we'll create a parameter with name time part. So, we'll take the date part only. So, rather than time part. So, from the date part, will will take. So what are the date parts in it? Year, month and day. So we'll take year, month and day here. And then we'll create a calculated field called date part, and then we'll use a formula to show the uh, part of the time part of the particular uh, particular function. So we'll actually use this date part um, parameter, and then so we'll in the date name calculated field. So here even before that, so we'll use in parameter, we'll be using only year, month and day, because in a date we only have year, month and day. So in date name we have what? So date part, and so in order date we'll take today. So we'll show this date part. We'll show date part into the, sorry, I have to change this date part. So I will change this date part and then make it as today. Right. So we are referencing the parameter here. So I'll show the date part into rows. So, and also show the parameter control. So if we show month, so it will show the date part will show the month number. If we show here year, it will, if we select year, it will show only year. If I take date, so it will take 28th. So today is 28th, month is 8th, so which is August. So year is 2008. So like that you can also create or extract a date part from today field as well. Okay, so you can play around to get your own required data using these functions. So the next date function is date add function. So we're discussing the date functions here, which is date add function. Okay, so date add uh, has a date part or a time part to it. So this date add function has date part. In this syntax we have in a date part or time part, and also an interval and followed by a date or date plus time. Okay, so date add requires uh, add. Okay, data requires to add the required date or time to the input date or date plus time field based on the interval it creates. Okay, um, so based on the interval it creates, and it creates a field of type date plus time. So what does a date add function do? So so basically it adds it adds a input date or time part to the input date or time, and returns creates a field of type date plus time. So we'll see that with an example. So uh, in date add, so we'll take the date part first. We'll take the date part as day, so we can take day, week, month or a year also. So for this example we'll take day, and we will we are adding days. So for days we are adding 10 more days. Okay, 10 more days. So we'll add 10 more days to today. We'll add 10 more days to today. Okay, we'll add 10 more days to today, then we'll see what the calculation is. So this is date add function. Okay, so today is 28th. So if we add 10 days, we have 31 days in this month. So we'll get 7th of September. Okay, so if we show that in the view, it will show. So we'll convert that into exact date. It's aggregating to year. We'll convert that into exact date and convert into discrete. So it's showing 7th of September 2018 because we have added 10 days to today. Okay. Similarly, so even for today, we can add or delete one or more days. So you can add today plus 1. So this will add 1 day to today. Okay. Convert it to the exact date and discrete. So today is 28th in IST. So if you add 1 day, it will be 29th. Similarly, we can delete a day as well. We can minus a day. So this will give you 27th. Okay. Right. So this is about date add. We also have date diff. Okay. So it finds the difference between the start date and the end date based on the date part. So we'll have to define the date part and also start date and the end date. So basically uh, based on the date part that we give here. So on the start date and end date, so it will take the difference and will show you the difference between the start date and the end date. Okay, the syntax is date diff of date part comma start date comma end date. So this is the syntax of date difference. So what it does, it takes the difference between the start date and the end date based on the date part. So you can take date diff of year, month, or a day. Okay, so first we'll take year. So the syntax is that if you are giving a start date, it should always be in hashes. So for example, we'll take one day. So this is a day. We should close that with a hash. It's a start day, and we have to give an end day as well. So we'll give an end day as 17th of April 2014, and we'll close this with a hash. Okay, so comma, yeah. So this is a valid function. So the in date difference, year is the date part, and start date should be enclosed within hashes, and end date also within hashes. So this is date diff function. Convert to measures and then drag that into row. So that will give you 1. So the difference between 17th of April 2013 and 17th of April 2014 uh, in the date part of year is 1 year. So similarly, if we change this to month, it will give you 12 months. The output will be 12. Okay. So if we if the difference is if the day difference If the start date is greater than end date, it will the output will be negative. So this is positive. So if we change this output, so for example, instead of 13, we are taking 14 here and 13 here. In the start date, we are taking 14 and end date, we are taking 13. So this will give you a negative output. So minus 12. Similarly, if you take the date part as year, it will give minus 1. Okay. So date difference gives the output always in integers. Okay. And also in date difference, in date diff, if a start date is greater than end date, so it gives the output in negative. So always you have to give the date values enclosed between hashes. Okay. So we have to give the date values enclosed between the hashes, and uh, it the output will always give the integers. And also, if the start date is greater than the end date, the output will be negative. Okay, right. Similarly, we'll also get the weekday and day as a same output given the date functions. Okay, right. Now we have one more function in dates called date trunk. Date trunk. Okay, so date trunk displays the accuracy of the dates. Okay, so accuracy of the date means displaying the start day, displaying the starting value of the dates depending on the date part. So accuracy of the date means displaying the starting value of the dates depending on the date part. For example, if you take year of today, it will, what is the starting day of the year of today? So that means if today is 28th of August 2018. So the start day of this year is what? 1st of Jan 2018. So date trunk will display 1st of Jan 2018 if you take date part as year and the date as today. So we'll see that. So date trunk in the date part will take year, and in date will take today. Comma today. Date trunk will, it is aggregated to year, so we'll show exact date. It is again converted to continuous, will convert into discrete. So today's date is 20th of August 2018. Uh, in date trunk, we have shown the date part as year and the date as today. So it is showing the first day of this year, which is 1st of Jan 2018. So basically, it displays the starting value of the dates depending on the date part. So if you take month, so what will it return? If you take month, what will it return? To return first day of this month. Okay, first day of August, first day of August. Okay, similarly for quarter, it will return the first day of this quarter, right? Okay, this is about date trunk, where it displays the first day of the date part that you uh, choose. Okay, and we also have date parse here. Okay, so date parse will convert the string dates to Tableau dates. Okay, so if you give any string date, it will convert that into Tableau recognizable dates. Date parts is not supported by all data sources currently. Maybe in the future versions, I mean, all that data sources will be made available uh, for date parts. So, okay, so for few of the data sources, it's available. So you need to check and see if date parse is working or not for after connecting to the data source. So the syntax is date parse of uh, string format and also date string. Okay, so for example, we can take um, date format to be um, dd yy. Okay, in quotations. Then third November 2013. Okay, so this is one example. So we'll see that date parse here. Convert into discrete. Okay, so 3rd of November 2013. So we have converted a string called 3NOV 2013 into a date part Tableau recognizable date Tableau date format like this 3rd of November 2013. So we are parsing a text, a string of 3NOV 2013 into Tableau recognizable date format using date parse like this. Okay, so you have to note that in date parse format, dd is a day, and it should always be in small d's, and is month, and it should always be in capital M's. Similarly, for year it should be 4 y's, and all y's should be small y's. Okay, so this is the format that you need to follow for getting the date Tableau recognizable date format from a string. Okay, right. So these are some of the date functions that are there in Tableau, and we'll look into type conversions now. So the next type of functions that are available in Tableau calculated fields are type conversions. So type conversion functions are used to convert the data from one format to another format. So if data is in one format and you want to convert into different format, you use type conversion functions. Type conversion functions. The syntax is function of expression. So the function could be int, okay, float, and etc. Okay, so int of expression, float of expression is the uh, syntax. Okay, so if you take int, so what it does is it converts input expression into an integer. Okay, it converts the input expression into an integer. The syntax is int of expression. So for example, if we take int and we take the function as int, and we'll take a fraction 5 by 2, so it will always return an integer. Okay, the output would be it should be 2.5 because it returns an integer, so the output would be 2. Output would be 2. So the output is 2 here because int returns integer of 5 by 2. So if you want a float or a decimal to be displayed, you simply change this to float. Change the function here, float of 5 by 2. It will return 2.5. It will return 2.5 like this. Okay. So you can change the name as well of the expression of the calculated field here. Okay, right. So we also have string function here, str. Okay, so it converts input expression to string. So what does the str function do? It converts input expression to string. The syntax is string of expression. String of expression. You can take uh, any value like row id. So and this will convert into string. All row IDs into strings. Okay, so these are all the row IDs and they are converted into strings. So we also have date time, make date time, okay, make date, okay, and make time. So these are also different type conversion functions. So we'll look into each one. So what does date time do? So date time, um, it converts the input expression to date time value. Okay, so the syntax is date time of expression. Similarly, we have date. So what does it do? So it converts input expression to date values. So it is date of expression. Okay, so it converts into date expression. So we have make date time. So this is a new function from Tableau 8.2. So it combines date and time values into date plus time fields. Okay, the syntax is make date time of date comma time, date comma time. So we'll take an example here. Make date time. Syntax is day and time. So day comma time, date comma time. So we'll give a input of date in hashes, in between hashes. So 3rd November 2013, comma. So we'll give time as well. So this is time. So we're giving date and time in make date time. So we'll take exact date and discrete. So it is combining both the date and time, then showing it as a date plus time field. So what does make date time do? It combines date plus time fields and will show it as a date and time value. Date and time value. Okay. You can also make today and now. So it is showing today's date and today's time as well. Okay, current time and today's date using make date time function. Okay, it is showing 20th of mm, August 2018 and 6:42 a.m. So it is showing the local time. Okay, so we also have make time here. So it will also show the hour values in 24-hour clock format. Okay, it will always show in 24-hour clock format. Right. So we'll also see how we can make make date. So we have make date. Okay. So this is make date. So this function make date is a new function added from Tableau 9.0 version. From 9.0, this function is newly added. So it takes input as multiple date parts and it combines them into a single date field. Okay. So here you can take multiple date parts and combine it and show it as a date field. For example, you can take year. So the syntax is year make date comma date parts. Okay. So year, month and day. Year, month and day. Okay. So if we can take make date 2013 is a year. Month is say 7 and date is 3rd. Okay. Day is 3. This is make date. We'll keep that as calculation to itself, or we'll make change it to make date. Yeah, we'll use that in the view. Yeah, so it has clubbed the year, month and day, the input that you have given, and it is showing it as a date in a date format using make date function. Using make date function. Using make date function, it is combining the year, month and a day input that you have given and then converting that into a date. Okay. Similarly, we can also make time as well. So using make time, we have to define the input should be hour, minute and second. Okay. So okay. So 7 hours, 5 minutes and 53 seconds. Okay. So you can uh, also make time like this. Okay, or minute and seconds like this using make time function. Okay. Right. So you also remember that all these time functions will take the hour value as 24-hour clock format. This make time function and all these will take the hour values in 24-hour clock format. So in make date, make time functions, all the date and time for part should be in the form of a integer. Okay. So you have to give the make time and make date format input in the form of integers like this. You should give the input in the form of integers only. Okay. So that it will be converting that into a valid date format. Valid date format to be used in Tableau. Okay, so those are the different logic type conversion functions. We'll now move into logical functions. So logical functions are used to perform the conditional evaluation in Tableau. Okay, so these logical functions are used, and these are predominantly used and most widely used functions, and very important as well in calculated fields. So why do we use these logical functions? We use these logical functions to perform the conditional evaluation in Tableau. So conditional evaluation means evaluating each and every value with the help of a condition. So evaluating each and every value with the help of a condition, we can do that. So there are two types of logical functions here. So there are two ways to performing a conditional evaluation here. So single condition evaluation and multi condition evaluation. Okay, so a single condition evaluation will check only a single condition at a time, whereas the multi condition evaluation will check multiple conditions at a time. Okay, so basically in logical functions, we have single condition evaluation and multiple condition evaluation. So in a single condition evaluation, we'll check only one condition at a time. So for example, in if we'll take multi conditions, okay, in case we'll check multi conditions. So in if we'll check only one condition. So we'll see that in our examples. Okay, so with the help of a conditional evaluation, we can design KPIs. We can design KPIs in our analysis. Okay, using conditional evaluations. Okay, so what are KPIs here? KPI stands for key performance indicator or key progress indicator. KPI stands for key performance indicators, okay, or key progress indicators. So these are the KPIs are the strategic goals defined by each and every organization. Okay, so the KPIs are the goals defined by organizations. So after some specific period, they will check whether they have reached the target or not by comparing the actual values with the targeted values. In the KPIs, they will define some targets, and after a specific period of time, they'll check the target values with the actual targets that we have reached or we have collected from the data, and we'll check with the targeted values. So okay, so um, these are the goals which are actually defined by organizations to compare our actual values with. Okay, so we'll um, try by making some uh, conditions using if if statement. Okay, so if iif stands for if and only if. Okay, we have if and iif. Okay, so iif stands for if and only if, so it performs single condition evaluations only. So iif, which if and only if, performs single condition evaluations. We have discussed that there are two ways to perform conditional evaluation. So in logical functions, will use logical functions to perform conditional evaluations. So condition evaluations are performed in two ways. One is single condition evaluation and two is multiple condition evaluation. So in single condition evaluation, we'll use if IIF, so which is if and only if. So it performs single condition evaluations only. So the syntax is if the condition test, then some result, or else some result. Okay, so the syntax is if condition then or else. Okay, so for example, if we take if sum of profit is the condition, sum of profit is the condition. Okay, sum of profit, we have to use an operator to check check the sum of profit, say 100,000. If sum of profit is greater than 100,000, then say it as profitable. So under then will show profitable. Under else you will show not profitable. Okay, this is IAF if and only function. So you are getting profitable. Okay, sum of profit is profitable in this case. The data we if we are summing all the profit values is greater than 100,000. So the value that we are getting is profitable. So this is a single value condition that we are checking the data against. So this is a single value condition. We are only checking if the sum of profit is greater than 100,000 or not using if and only if function. Okay, so using this um, if and only if function, we can also do some conditional formatting. So this is called as spotlighting in Tableau. Okay, this is called as spotlighting in Tableau. So if we are coloring the values depending on a condition in the visualization, then such type of a coloring is known as a spotlighting. Okay, so if you are coloring the values depending on a certain condition in visualization, then such kind of a coloring is known as a spotlighting. Okay, it is basically performed on a text tables. So we'll see that using an example. So we'll display year wise and month wise profits. Okay, and if the profit is more than 100,000, then the spot will spotlight the values in green color, else we'll spotlight them as red color. So for that, we'll first create a calculated field with the name um, profit KPI. You create a calculated field and name it as profit KPI. Here, the formula that we'll use is if and only if sum of profit is greater than 100,000. Then green will indicate it by G and red color will indicate it by R. This is else. So then condition in then it will be G. In else it will be R. We'll close this. Click OK. Now we'll drag year into columns. And then month into rows. Right. So now we'll drag profit into text. Okay, we have all the profit values in text like this. and we'll use profit KPI into color. And in color window, we'll assign green color to G and then red color to R. So if any value is less than 100,000, it will be shown in red. And if something is greater than 100,000, all those values would be shown in green like this. So this is called as spotlighting using if and only if condition in Tableau. Okay, so if and only if condition or function can be used for showing spotlighting feature in Tableau. Okay, so we also have one more feature where we can display the required shapes or symbols along with the values or in place of the values. So for example, if you want to show uh, a tick mark when the profit is positive and a cross mark when the positive is not profitable. So, and we want to show that in icons rather than in numbers for each row and column. For each cell, we can use a feature called as scorecarding. So, which will display the required shapes or symbols rather than the values here. Okay. So we'll do a task to actually show scorecarding here. Okay, so we'll use the same profit KPI calculated field that we have uh, created in this example. Okay, now uh, we have to choose in marks card shape because we will be displaying shapes here. So in shape, uh, we'll assign. So first we'll go to shape and then select shape in marks card. Okay. So we'll drop profit KPI into shape. Okay. We are getting shapes as G and R in profit KPI. So in shape window, so we have to assign green tick for G and red cross for R. So we'll click on edit shape and we'll select the KPIs here. So for green, we'll use a green tick, and R will use a red cross. Click on apply. Now we'll click on label and then we'll uncheck show marks label. So this will show a scorecarding view like this, where uh, we can show different symbols or shapes in place of the values. Okay, so these kind of visualizations are known as scorecards. Okay, you can prepare scorecards using if and only if condition like this. Okay, right. So these are the single condition evaluations. So we'll take a quick break and we'll come back and then look into multi condition evaluations in Tableau using uh, these logical functions. Okay, so we'll come back in a couple of minutes. Any questions till now?
No, I'm good, Kranti.
Okay, fine. So we have discussed about spotlighting and scorecarding for single condition evaluation. So now we'll discuss about multi-condition evaluation. So in Tableau, multi-condition evaluation is done using two types of functions. So one is if function and other one is case function. So one is if function, another one is case function. Case function and if function. So using these two functions, we'll be doing multi-condition evaluation. So the condition, the syntax of if function is, so if condition, then it will the return one. So else if condition two, then it will return the second return. So you can use number of else ifs and condition 3, 4 and so on, then return 3, 4 and so on. So the finally else you can also use other, and you'll have to end that with a end. So this is the syntax for if condition, if function, if function. Okay. So here the behavior of if and case are uh, same, but syntactically, syntax syntax wise they will differ. Syntax wise, if and case statements will uh, differ. Okay. So we'll see about case statement after we are done with this if statement. Okay. So in if condition, so we have to always take in between conditions in the else part to improve the performance of any calculation with if condition. It also applies with the case condition as well. So we'll do that with an example, so that we can understand this better. So now we'll perform a task uh, using multi-conditional uh, coloring. Okay, this is a multi-conditional check, right? So this is a multi-conditional evaluation using if condition. So we'll display, the task now is to display country-wise sales and design a sales KPI where if sales is more than 100,000 or 1 million, then indicate the countries with A in green. And if its sales is between uh, 500, uh, 500,000 and 1 million, then will indicate this with B and orange color. Else we'll indicate all the rest of the countries with C in red color. So this is a multi-conditional coloring evaluation using if condition. So for that we'll first create a if condition. Okay, we'll first create a calculated field with the name as sales KPI. Okay, sales KPI 2. So we'll use a if condition in this calculated field to create a calculated field. So the formula is if sum of sales is greater than 1 million, then A. Else if sum of sales is greater than or equal to 500,000, and sum of sales is less than or equal to 1 million, then B. Else C. You'll end the statement with end. So this is one way of doing the calculation. However, to optimize the calculation, or better to improve the performance. Okay, so we'll just modify the calculation a bit, so that so we'll reduce the number of calculations in the calculated field. We'll make these as comments, and so we'll keep, if sum of sales is greater than 1 million, then A. We'll use else if sum of sales is less than 500,000. Okay, then C, else B. So this will actually uh, optimize the calculation in terms of performance. It will also better the calculation in terms of performance than the before calculated field. So we are just using less calculations. Rather than two conditions, we are using only one condition, so that the performance increases. Performance increases. So rather than two queries, we are just using one query. So we have to optimize the calculations like this. Okay, and click on OK. We'll clear the sheet. We'll click on country region calculated field. This will give you a map view like this, and we'll drag sales into label. This will show the sales in numbers like this, and then sales KPI 2 into color. So this will create a field map like this, showing sales by color. So we'll change the colors. So for A, we'll keep green. So for B, we'll keep orange. Well, it is okay. And for C, it is red. Click on OK. So that means, so for all A's, so we have sales greater than 1 million. So these are the countries which are having sales greater than 1 million, and which is represented in blue, sorry, green, and the countries which are in between from 500,000 and 1 million are in orange: France, Russia, Egypt, Pakistan, and so. We also have sales which are uh, less than 5,000, less than 500,000. So which are Canada, Australia, and so. Okay. So 1 million greater than sales are US, Mexico, India, China, Brazil, and Argentina. Okay. So like this, we can create multiple condition evaluation, also using multi-conditional coloring, also using if statement. Okay, so this is one of the ways or an example to do this. Use this function called if. Right. We can also create multiple conditional statement using a case statement. So we'll see how we can use a case statement. So case is basically an alternative to if statement. So case is used to perform multi-conditional evaluation, like if. The syntax of case statement is case of expression, so case of expression, okay, so when we have value 1, then it will return one value, else value 2, it will return, then it will return 2. When value n, then it will return n. So else others, when it will end with a end statement. Okay, so we'll try to actually create a multi-conditional evaluation using um, case statement. We'll take a simple example for case statement. So we'll extract the quarter name using case statement, case function here. Okay, so we'll create a calculated field. Okay, so for quarter names, so we'll use case statement. Here we'll use date part, the date part that we'll use is quarter, and the date will be used is order date. So in case we are taking date part of quarter of order date, so when, so the quarters will be 1, 2, 3, and 4. So when 1, then you have to convert that into quarter 1. Similarly for 2, 3, and 4. When 2, then quarter 2. When 3, then quarter 3. Else quarter 4, Q4, and end. Okay. So have created a calculated field using case statement for multi-condition evaluation. Now click OK, and then drag this calculated field into rows. This will show you all the quarters which are underlying as 1, 2, 3, 4 as one quarter 1, quarter 2, quarter 3, and quarter 4. Q1, Q2, Q3, Q4, like this. So we have to remember that we have to always use case while performing dimensional evaluations. So if you are using dimensions, then you have to always use case. If you are using measures, then you have to use if. Okay, so you have to note here that you have to always use case while performing dimensional evaluation, and use if while performing measure evaluation. So in our earlier example, for comparing a measure, so we have used if condition. Okay, so sum of profit, what profit is a measure, sum of profit is greater than 1 million. So for that we have used if condition. So for case we have used uh, order date. So order date is a dimension. Order date is a dimension. So we have to use case while performing dimensional evaluation, and if while you are using measure evaluation. Okay, when you are performing measure evaluation. Okay, so because we are giving number of conditions in if and case statements, so the performance of if and case completely depends on the number of conditions that you give in the formula. Okay, so you have to be doing some optimization to give as less conditions as possible, because that will run into a loop. So um, the performance also depends upon the number of conditions that you give in if or case statements, okay, in the formula. Okay, so you have to always optimize the number of conditions you give in this. So this is the multiple condition evaluation that you can do using if and case statements. Also, you can use case statements using parameters as well. So for example, we have continent here in dimensions. Okay, what are the continents here? It's Africa, Asia, Australia, Europe, North America, and South America. So we can create a parameter, name it as continent parameter. Data type is string, and we'll take a list. We'll add from the field called continent. So these are the values. Click on OK. So we'll create a calculated field using case statement continent. So in case, we can refer to continent parameter. Continent parameter. Okay. So when Asia then sales. And the case should be the same in both the uh, values that you give in parameter and also in the calculated field. So we'll check that. So North America, no N caps and A caps, Asia. Similarly, we can define any conditions like this and end the statement. Okay, so you can also use a case statement like this by creating a parameter and referencing that parameter into a calculated field like this. Okay, so if you select Asia and also North America, you'll be getting values like this. Okay, so it is taking sum of sales. If you are taking any other uh, continent, it's showing null, because in condition we have defined only Asia and North America. Okay, so even like this, you can create a parameter and reference that into calculated field. Okay, using case statement. So The next type of functions are null comparison functions. So we have if null. So we'll see one by one. We have if null, is null, is date, and so on. So we'll see one by one. So what is if null the? So this is null comparison function called if null. So if null takes the input as two expressions. So if expression 1 is null, it returns expression 2. So if it is not null, it will return exact value of expression 1. Okay. So if expression 1 and expression 2, then it will take the statement or and uh, and. So this is the syntax is if null expression 1 and expression 2. Okay. So if null takes the input as two expressions like this. So if expression 1 is null, if expression 1 is null, then the return value will be expression 2. Okay. If it is not null, it will take the exact value of expression 1. Okay. So we'll see that with an example. So we also have is null. So is null checks if input expression is null or not. So is null will check the input expression if it is null or not. If it is null, it will return true, else it will return false. Okay. What is the output? So is null will check if the input expression is null or not. If it is null, it will return true, else it will return false. The syntax is null of expression. Okay. So we have to note that in Tableau, any function which starts with is a Boolean function. Okay. So if is date, is null, all the functions that is starting with is in Tableau is a Boolean function. So what is Boolean function? Boolean function means the result would be either true or false. The result is either true or false. So those are the Boolean functions. So any function starting with is in Tableau is a Boolean function. Okay. So to perform null comparisons in Tableau, if null and is null functions are used. Okay. So to perform any null functions, null comparison functions in Tableau, if null and is null functions are used. So for that, I will actually create uh, create an example. Will perform a task to understand this. So we'll first create a text file. So here we'll create product and sales. A comma 100 and B comma null. Okay, we'll save this. We'll connect to this sheet. So here we'll create two calculated fields. If null of sum of sales comma 0. Similarly, we'll create one more calculated field, is null. So from product, we'll keep drag that into rows. Okay, and then sales into columns. So is null into rows, and if null into columns. Okay, so instead of showing 0 in if null, so if you want to display some text value, we'll create a calculator with the name modified sales. Um, so we'll create a formula. Modified sales. So in this formula, if we will use if null, we'll use string of sum of sales, no value. Now we'll drag this modified sales into rows. Okay. So like this, we can show um show the values using if null and is null functions. So is null is a Boolean function where it will show uh, either true or false. So if the value is null, so is null will show true. If the value is not null, it will show false. Okay. So similarly, if null will if the using if null, so it will calculate the two expressions. If the expression one is null, it will return the expression two. So what are the different expressions that we have taken here? Okay, sum of sales and 0. So uh, if expression is null, so if the sum of sales is null, then it will return uh, 0. Okay, or else it will return uh, it will return sum of sales itself. So because the sum of sales is 100 here, so it is showing 100. So when in product A's case, in product B's case, it is null, so it is showing 0, or we have modified that into no value, so it is showing no value in that case. Okay, so That is how you can use if null and is null conditions or functions in Tableau. Okay, we also have is date here. Okay, so um, is date checks whether the input expression is valid date or not. Okay, so what does this do? So is date checks whether the input expression that or a string that you give is a valid date or not. So if it is a valid date, it will return true, else it will return false, because it's starting with is, it's a boolean function, so it will either return true or false. Okay, so if for example, so we'll also we'll also take not expression. So even in is null, we can take is not none also to take a negation expression as well. Okay, so here to check uh, is date, so we can use any date format, and they should always be in quotations, and they should return either true or false like this. Okay, so these are the different logical functions that we have in Tableau. So now we have aggregate functions as well. We have aggregate functions in Tableau. So aggregate functions combine the individual values and it gives the single consolidated value or aggregated value. So what does aggregate function do? A function aggregate function combines the individual values. For example, if there are 100 customers, so an aggregate function like count or count distinct will count all the customers and then show the sales of all the customers in a single value. Similarly, for sum of sales or average sales, we can use those are the different types of aggregated functions. These are used to consolidate the values or aggregate the values. So aggregate functions combine the individual values and by for giving single consolidated value or aggregated value. Okay, so there are different aggregate functions in Tableau. So those are sum, uh, min, max. Okay, there is sum, there is max, there is min. Okay, there's average, there's count distinct. Okay, so these are all different aggregate functions. Okay, there is average, there's count distinct. Okay, so these are all different uh, aggregate functions. So there are certain rules to perform aggregations also. Okay, so there is there are certain rules. So rule number one is we cannot place one aggregation inside the another aggregation. Okay, so if a field is already an aggregate, or if you are aggregating once, we cannot place one more aggregation inside other aggregation. Okay, so for example, if you use sum of average of sales, then it is a invalid field. So expected, okay, it is an invalid field. Okay, so you cannot define, cannot place one aggregation inside the other aggregation. So this is rule number one. either you have to take average, or either you have to take sales sum. So either you have to take average or you have to take sum. So only one aggregation. Okay, like this, right? The rule number two is we cannot combine or mix aggregations with non-aggregations. Okay, so we have to either take aggregations or take non-aggregations. We cannot combine one aggregate and one non-aggregate. So the example is, if you are taking average sales, and if you want to combine with profits, okay, this is not a correct form to do it. Here sales is aggregated, take average or even sum. So sales is in aggregated form, whereas profit is in non-aggregated form. So you cannot combine or mix aggregations with non-aggregations like this. So we have to take both aggregations and then do the calculations. Okay, we have to do aggregations like this, or calculations using aggregations like this. So you cannot mix both, mix non-aggregation and aggregation. So this is rule number two. So rule number three is we can combine aggregations with uh, constants and other aggregations. Okay, for example, um, you can combine a constant like, say, sum of sales into 5. So 5 is a constant here. Okay, so you can combine aggregates with a constant. Okay, or other aggregation. So other aggregation is in the simple, in the previous example, the other aggregation is profit here. So we can combine aggregation with an other aggregation or a constant. Okay, we can combine. So the calculation is valid. This is the, you can combine aggregation with other aggregation or a constant, or a constant like this. So the calculation is valid. Okay. So this is rule number three. So rule number four is we cannot evaluate or compare aggregations with non-aggregations. Okay. So we cannot evaluate or compare non-aggregates with aggregates with non-aggregates. Okay. For example, um, max of sales, comma, sum of profit. Okay. So cannot mix aggregate and non-aggregate arguments with this function. Okay. So what is the problem here? We cannot evaluate or compare aggregates with non-aggregates like this. So sales is a non-aggregate field and sum of profit is a aggregate field. So we cannot evaluate or compare aggregates with non-aggregates like this. Okay. So that is rule number four. So rule number five is we can evaluate or compare aggregations with aggregates or constants. Okay. So for example, so max of sum of sales, comma, sum of profit. So this is a valid field. Okay. So we can evaluate or compare aggregations with aggregates or even constants. Okay. So these are the different rules that you have to consider while working with aggregates. So we have to note here that inside the formula, if we take any aggregation and we drop that field into columns or rows, Tableau will indicate that field with AGG, which means it is already that field is aggregated. Okay, so for example, um, we are using this field and dropping that into the view. So it is showing as AGG in the view in Tableau. So um, if you are in the formula, we are aggregating using sum, right? So we are aggregating within the formula itself, and then we are dropping that field into the view, either columns or rows in Tableau, and then it will indicate as AGG. So what it means is, it is the field is already aggregated in nature, and you cannot further aggregate this field because in the formula sum is already applied. So further aggregation cannot be applied on this field. So if you use AGG, if you see AGG, that means the field is already aggregated in nature. Okay, so this is about this AGG field, AGG aggregation, and we also have median. So median. So it gives the mid value of the set of numbers. So median gives the mid value of the set of numbers. So if the number count is even, then the median is average of the middle numbers. If the number is odd, it is the middle number. Okay. If it is even, it is the average of the middle numbers. Okay, so if you take median of profit value, so for each and every continent we can calculate the median. So okay, we'll first will what we'll do is we'll create a calculated field uh, with the name median, uh, with formula median of profit, and now we'll show continent into rows, then median into columns. Okay, so and sort it, and also show median and label. Okay, these are the different median values for different continents. Okay, right. So in median we are calculating the median for profits. So this is a median for different profit values for different continents. Okay, so we can calculate the median value like this. So the next function is attribute function, indicated by attr. Attr, attribute function. Okay, so it stands for attribute function. We have to note here that attr values are not visible in the data window, unlike other aggregate functions. Okay, so uh, if you see aggregate functions, they will be visible. Sales aggregation will be visible in the data window like this. However, attr values are not visible in the data window. Okay, because attr function will execute at the Tableau level or a sheet level. Okay, so they will not be executing at the data source level. So if they are executing at the data source level, they'll be visible in data window. However, attribute function will execute at Tableau level or a sheet level. So that's why they will not be visible in under data window. The syntax is attr of expression. So where is it used? Where is this attribute function used? So it is used to aggregate the non-aggregated fields or dimensions. So it is used to aggregate the non-aggregated dimensions. Okay, so it is also used to check the values. It is also used to check the values. Okay, So now basically, if you want to check the values, or um, if you want to aggregate a non-aggregated dimension, then you will use a attribute field. So the logic of this attribute or a behavior is, uh, if minimum of expression is equal to maximum expression, then minimum expression. So for example, if you take minimum of expression is equal to maximum of expression, then minimum expression, uh, else it will return star end. So that will create a uh, attribute function. So we'll actually perform a task to understand this better. Okay. Um, so first in display we'll display continent wise profit sales ratio. Okay. If the if the continent is having least profit sales ratio, then we have to double the value of that continent, else display the actual value. Okay. So for that we'll create a calculated field, and then name it as modified. So first we'll actually create a proper calculated field. We'll name it as profit or sales ratio, sale ratio. The formula that we use is sum of profit divided by sum of sales. So this is a profit sale ratio. We'll clear this view and we'll drop continent into row and profit sale ratio into columns. We'll create another calculated field with name modified profit sale ratio. Here, the formula that we use is if ATTR of continent equal to North America, then profit sale ratio into 2, else profit sale ratio. Now we'll drag this modified profit sale ratio into columns. Okay. So basically we have uh, used a ATTR function uh, to convert the non-aggregate field into a aggregate field. Okay. Using ATTR function, right? So we'll perform one more task to find whether a state is existing in uh, another country or multiple countries. Okay, so we'll create a parameter with name state, and the list all the state values, and then we'll display the parameter. We'll display the parameter. So we'll create a calculated field with name, checking country, and we'll define some formula in this. So in the formula, we'll use if state equal to state parameter, then country or region, else not existing. And okay, now we'll place state and country into rows, and checking country into columns. Now we'll drag sales and drop it into rows for 6 times. I will change the aggregation to minimum, maximum, average, count, and median. We'll keep sum as it is, and we'll change the aggregation to minimum, maximum, average, count, and median. And in show me, we'll use table. Okay, so for each checking country, so we'll have um, the average sales, count of sales, maximum, minimum, medium sales, and sum of sales. Okay, and based on the selection, we'll have the different sales values like this. Okay, so these are the different aggregations that we can use in Tableau. So we have to note here that from Tableau 9.0, include, exclude, fixed functions are newly added in aggregation. Okay, from 10.2, collect, correlation, covariation, covar p are also newly added in aggregations. Okay, so in aggregate functions, if you get star as an output, it means that input expression contains multiple values. Okay, so in aggregate function, if you the output is star, so that means the input expression that you have given at attribute function is having multiple values in it. Okay, so these are the different functions that we use in calculated fields that to perform different user defined calculations and modifications of the data. For in tomorrow's class, we will look into table calculations. So table calculations are uh, also a type of advanced calculations that are executed at the Tableau level. So we'll discuss about table calculations in tomorrow's class. Okay. So any questions till now?
No, I'm good, man. Thank you.
Okay. Yeah. See you tomorrow.